Bismillah ar-Rahman ar-Rahim. We will discuss applications of ellipses to engineering problems. In this exercise, we have exercise 1, the smallest elliptical, semi-elliptical arc in the concrete bridge in the opposite figure must have a clearance of 200 feet. The clearance here 200 feet, the altitude above the water. Here is the water, and span distance of 40 feet. This distance is 40 feet from this point to this point. Find the equation of ellipse at this case and then determine how much clearance above water is there 5 feet from the bank. This is the second demand. To solve this problem, we will do the following. First, we will graph the problem. We have this elliptical bridge like this. Then we have clearance. This is the clearance of the bridge. How much? To 12 feet. The bridge spans 40 feet over the water. Because of the symmetry of the ellipse, this total distance 200 feet is 20 from here to here feet and 20 feet from this point to this point. So to determine the equation of the ellipse, this ellipse represents an ellipse in the second case, in the first case. So the equation has the form, it is an ellipse in the first case. Why? Because in the first case, the major axis of the ellipse must be aligned on the x-axis. And if this is a case of a bridge, to be able to moving on this x-axis, this must be the x-axis. So this ellipse represents an equation of the first case, which has the form x squared over a squared plus y squared over b squared equal 1. A here is the distance from the center to this point, so A equal 20, and B is the distance from the center to this point, so B equal 12. And here we can consider the origin is the center here at this point. So now the equation of the ellipse is x squared over a squared, a here 20, so 20 squared plus y squared over b squared, b here equal 12, 12 squared equal 1. Finally, the equations become x squared over 400 plus y square equals over 144 equal 1. This is the equation of the ellipse. The second demand, he said, how much clearance above the water is there 5 feet from the bank? This means that he wants to know the clearance y over the water when the distance is 5 feet from the bank. This is the bank here. So if we redraw this ellipse, here is the y-axis, here is the x-axis. So the total distance here is 20, but from here to here 5. So the remaining from here to here x. So x in this case equals 20, the total distance from here to here, 20 minus 5 from here to here. So x is 15 at this point. So to determine this y, this clearance y, we need to find the coordinate of this point, which x equal 15 and y. Now the point 15 and y, now the point 15 and y lies on the ellipse. Since this point 15 and y lies on the ellipse, it is, of course, satisfies its equation. The equation of the ellipse is x squared over 400 plus y squared over 144 equal 1. So we can put x as 15 and y is the unknown. This implies that 15 squared over 400 plus y squared over 144 equal 1. So we can solve this equation for y and obtain y squared over 144 equals 1 minus 225 over 400. This implies that y equal positive square root of 144 multiply 1 minus 225 over 400. Finally, y approximately equals 7.9373 feet. This is the first problem. The second problem said if all possible wing shapes, it has been determined that the one with the least drag along the trailing edge is an ellipse. The leading edge, this is the leading edge, may be a straight line as shown in the opposite figure. This is the leading edge. One of the most famous planes with this design was the World War II British design. The plane in the figure, the opposite figure, has a wingspan of 48 feet. Where is the wingspan? This is the wingspan. This line is the wingspan. It total equals 48 feet. So if we need to graph this wingspan, we can graph the ellipse like this. This is the elliptical wing. This is the wingspan. We can draw here the x-axis, and here is the y-axis. It is mentioned in the problem the wingspan from here to here was the major axis in the ellipse. The wingspan in the plane is the major axis in the ellipse, equals 48 feet. يعني this is 24 feet, and this is 24 feet because the ellipse is symmetric with respect to the y-axis, which passes on the center of the ellipse. If the straight line leading edge is parallel to major axis of the ellipse and is 1.14 feet in front of it, if the leading edge is 46 feet long, this is the leading edge. This line is the leading edge. It is 46 feet. Also, we have symmetry with respect to the y-axis. So this point is 23 feet, and this distance is also 23 feet. Find the equations of the ellipse. First demand, we need to find the equation of this ellipse. To determine the equation of the ellipse, we have this equation. We can consider the major axis lies on the x-axis, so the equation of the ellipse has the form x squared over a squared plus b squared plus y squared over b squared equal 1. A here is equal 24 because the major axis equal 48, the wingspan, so A here is 24. Now the equation becomes x squared over 24 square plus y squared over b squared equal 1. So if we could determine b, we can know the equation. How to determine b now? By knowing a point lies on the curve of this ellipse. If we substitute x and y in this equation, we can know the value of b. For example, this point, it is mentioned in the problem, the leading edge, this line, the leading edge is 1.14 in front of the wingspan. So this distance is 1.14 feet. So we need to determine y as x equal, so x equal 23 and y equal 1.14, because here the distance, the height is 1.14 and x is 23. So this point is known. X 23 from here to here, y is 1.14. Now, since the point 23 and 1.14 lies on the ellipse, it satisfies of certainly its equation. يعني then we put here in the equation, instead of x we put 23, but 23 square over 24 square plus, we can substitute here instead of y 1.14, 1.14 square over b square equal 1. Now we have in this equation only a known value for b. Solving this equation for b, we have b square equals 15.9270127,203. Solving this equation for b. Now we can take the square root. This implies that b equal root this number, which approximately equals 3.991. The final demand: how wide is the wing in the center of the fuselage, assuming the wing passes through the fuselage. يعني he needs to know the width of the wing, the width of the minor axis. He needs to know the width of the minor axis. Here is the minor axis. يعني this means that he wants to know this length, all this length from this point to this point. So this width equals 2b. He needs to determine 2b. b equals 3.991. يبقى approximately equals 2 multiply 3.991, which approximately equals 7.98 ft. And thank you very much.